All right, ladies and gentlemen, we're going to continue our discussion of conformation. Now we're going to apply it to what we call chairs. Chairs are the preferred conformation for cyclohexane. In a chair conformation, there are no angles other than 109.5, and that's the ideal angle for an sp3 carbon, right? And in a chair, there is no eclipsing at all, which is good news. Eclipsing causes, what's that called when groups get close in space? Steric hindrance. That's a form of steric hindrance, eclipsing. Chairs can avoid that. And I'm assuming you're eventually going to watch the video on how to draw chairs, because it's step by step. I'm just going to jump into it, assume you know it, even though I know most of you don't. But you'll be watching this video after you watch that when you start studying, right? Because this is a problem video. I'm going to sketch a cyclohexane with my two groups on it here. You get no points up here, by the way. This is not a chair. That's just a good old flat hexagon. And then other videos, you'll see if you draw it flat, there's nothing but eclipsing. Flat's not cool. All right. And we got a group called a hexyl on carbon 1. I put that in blue. 1, 2, 3, 4, 5, 6. And on carbon 2, we have an isobutyl. Get used to me calling isobutyl IBU. Yeah, and some of you know why. One of the most common medicines out there has IBU in its name, doesn't it? Why does it have IBU in its name? I drew it in red. It's got an isobutyl group on it. Ibuprofen? Yes, sir. Ibuprofen. So it's cis. I haven't shown cis here. How do you want to tackle it? You've got two options. You just tell me the one you want. 2 wedges works for me. Red wedge, blue wedge. Oops, wedge. He said wedge and I. Remember, for future reference, we got, in our normal look and our chair look, up in the chair comes from wedge in the normal drawing. We did a normal drawing right here. No, your name is not normal. Okay. This is the normal drawing. Wedge is up. So in a chair, I'm going to draw these bonds both up. Can you remember that? And a dash in the normal would result in, you probably guessed it, a down bond. Okay, that's just set up. Now, when you get to the exam, I'm expecting you to be able to draw 2 nice chairs. And I'm going to go monotone here in the order that you'll do it. Parallel lines on an angle. From the inside corner, parallel lines more than halfway towards the other line. And then just finish it off with 2 more parallel lines. It's all about parallel lines. And as a child of the 70s, I can tell you about a record that was called Parallel Lines. Big hit for Blondie. Anyway, what's he talking about? So what do we have? Carbon 1 and 2, you decide. I have a comment on that. In a room of 20 people, if I'm grading this question, it takes a long time, period. If everybody has a different approach to starting this question, it takes longer for me to grade it. But more importantly, I'm not in as good a frame of mind. I'm just being honest with you. What kind of teacher you want grading your exam? One who's a little agitated and irritated, or one that's in a nice, calm frame of mind? Yeah, you like the second guy. So if everybody decides on this question to approach it this way, where you draw your first chair, and carbon 1 is in the top right corner, and carbon 2 is in the bottom right corner, You have made your teacher a little calmer. You do not have to do this. But if you choose not to, keep in mind, you're contributing towards the agitation of your teacher. It just takes me longer to grade the test, and I'm an honest person. It's going to make me more irritated, okay? So if everybody decides to go top right for carbon 1, it just makes me a little calmer. And in your other chair, when you draw it, I will tell you where an appropriate carbon number 1, 2 combination will be. Now, it's going to look like this chair is a mirror image. This is not what's happening. We're going to take, I don't have a cyclohexane here, but in other videos, when I have the cyclohexane, I do the sigma rotation with the toys, and you'll see that every time a carbon is bonded to a carbon on an upward angle in the first chair, after the sigma rotations, that same carbon will be pushed down. And any carbon angle that started on a down orientation, see how that's pointing down? In the next chair, when you do sigma rotations, it ends up pointing up. It's just a fact. I mean, it's real. Watch videos, there's toys. So when you do the rotations, that whole speech, and it's going to look like the mirror image somewhat, that whole speech was, please don't pick a carbon 1 where it's still sticking up. Don't go top right is what I'm saying. It's still sticking up, isn't it? That's not even the same carbon as before. And shame on me for being the teacher. That is not parallel to the one across, is it? It's close. I might be forgiving grading this one, but you know, it's supposed to be parallel. Come on. Nah, got the whole thing. There. If everybody goes bottom right for the 1, content teacher. And notice it's pointing down. In reality, any of the carbons pointing down is a candidate for salt carbon 1. Content teacher candidate is bottom right, okay? Any of the other 2 positions for number 1 would be okay. It's just, I'm rotating stuff, grading, and getting cranky. Okay, so we're setting up. And I didn't explain why I'm only concerned about carbons 1 and 2 in this question, but I think you can figure it out from the question. If I had a group on carbon 3 in the question, I would have gone to 3. If I had a group on 4 in the question, I would have gone to 4. You will see in our next example, there's groups on 1 and 3. I will be going to 3. Now let's see who's paying attention. Carbon 1 has the hexyl. And sadly, carbon 2, I went counterclockwise here. It's okay. Nobody grades that one. I got this sentence here. It says, if it was a wedge in the normal, it better be up in the chair. I want to draw the bond on carbon 1 to this hexyl group. Right there. Straight up. Straight up. And then CH2 5 times. 1, 2, 3, 4, 5. CH3. 6. Okay. I should have told you something first. You ready for the something first? Maybe not. I need to see all the bonds on carbon 1 and 2 in this question. Why I know it's 1 and 2? There's groups on 1 and 2. The next question we do, there'll be groups on 1 and 3. I want to see all of the bonds on 1 and 3. I don't care about any of the other carbons. You've already drawn them, you're done with them. The bond you start with is always the bond that follows the carbon angle. That direction is up. Please draw this up bond first. On carbon 2, the carbon angle points what? Up or down? Down. Please draw straight down. Those are called the axial bonds. Axial. Think about, we're in astronomy mode today, okay? We've already talked about eclipsing. Think about astronomy. The axial is referring to the axis of the Earth. Isn't that the line up and down the Earth rotates around? Well, axial here means straight up and down. Half of the bonds sticking off of the ring are straight up and down, and they are called axial. The other half are around the outside of the ball. On the Earth, when you're living around the outside of the ball in that very hot region of the Earth, what region is it? The equator. We call those the equatorial groups. We haven't drawn any equatorial bonds yet. We're going to do them next. You ready? On carbon 1, the axial was straight up. Therefore, the equatorial is slightly down. Oh. The equatorial on 1 is slightly down. And I would also like to point out there's a relationship between that and that and that. And please tell me that relationship. They're parallel. Equatorials are always parallel to the adjacent bond. Notice I didn't say to the adjacent bond. No, this is not parallel to the adjacent bond, but it is parallel to the next one over. Got it? Talk to me about equatorial on carbon 2. Use the words to describe the orientation of the bonds, please. 2 words. One refers to that position or that position, and the other refers to down, up or down. Well, I just said that, up or down. Oh, I gave away the answer. Is it up or down, the red bond that's equatorial? Up. You already have the down bond. It was called axial. There's always one axial and one equatorial sticking off the ring for each carbon. There's always 1 and 1. There's always, if the axial's up, the equatorial's down. If the equatorial was up, the axial was down. You can't have both up or both down. Okay, that's just not, it's not the separ. Okay, the separ says evenly spaced, right? Okay, so you told me slightly up, maybe you didn't, maybe, I don't know. And parallel to, not the adjacent to the adjacent. New highlighter. Go baby blue. That is parallel to that and that. At least I did a pretty decent job, right? I don't need these highlightation. That's a new word. I don't need those on your activity or your test. So reminder, draw the axials first. They follow the carbon angle. That would be axial straight up if the carbons were meeting like this. If the carbons are meeting like this, they're pointing down. The axial is straight down. That's why we start with axial, because everybody can do straights and straights, okay? If the axial was straight up, the equatorial will be what? I need more. You gave me half an answer. Somebody said down. I agreed. Don't say straight down. That's axial. No carbon has 2 axial bonds. And you already told me the axial was straight up. Equatorial is therefore slightly down. If the axial is straight down, what is the equatorial? Don't just give me half the answer. She said up. Slightly up. Okay. When is it straight up or straight down? What's the name of the bond? Axial. Equatorial. Slightly up or slightly down. Got it? Got it. And there's parallels for equatorials, right? Now we're going to go back and put this group on. Remember we said this blue group is up because it's on a wedge? Which of these 2 bonds is up? There's only one of them that's up. Axial. Put the butyl on, or hexyl on there, sorry. 1, 2, 3, 4, 5, 6. And please don't leave a stick here. That's a methyl. Is there methyl in the name? Please don't leave a stick here. I do want to see the bond. On the carbon where there's a group, I need to see all 4 bonds. You're not allowed to skip H's on those carbons. I need to see the H. Okay. I don't care about carbons 3, 4, 5, and 6 in this question. I only care about carbons 1 and 2. Back to the red isobutyl. Is it up or down? It's a wedge. Therefore, it is up. Which of these 2 bonds is up? Equatorial or axial? Equatorial. Draw the IBU. We got the CH2 already. CH. Don't leave the end of a stick naked. That would be a methyl. So what do I put there? H. Okay, part A is done for the first chair. And let's do the whole process over again for chair 2. Who remembers what bond I drew first on carbon 1 and 2? Axial, because it follows the carbon angle. Carbon 1, the angle is now what? Up or down? Down. Axial is therefore straight down. Okay, sticking with blue, carbon 1. The equatorial on the same carbon. Tell me the words for the direction. No, you can't have two axials on a carbon. Somebody said straight up. I do not like this answer. You have one axial. Those are the straight. Equatorials are always the slightly. Okay? If the axial was straight down, which it is, the equatorial is slightly up and parallel to the bond between 2,3 and 5,6. I'm not going to highlight this time. That's parallel to the bond between 2,3 and 5,6. What do you draw on 2 first? I want to hear the word axial or equatorial, and I want to hear the direction. Axial and the direction. Straight up, yeah. Equatorial. If the axial was straight up, the equatorial is slightly down. I want it parallel to 1,6 or 3,4. So it is slightly leaning to the right. I know it looks almost straight down, so I'm gonna cheat a little. It's not quite parallel, but I don't have it straight down. You know why I had the issue there? I drew this bond a little too vertical. Life would have been a little better. And hey, learn from other people's mistakes. I'm going to improve my answer with a little better angle to begin with. I won't have the trouble drawing that equatorial now. See, it's not straight down. So I just like it a little better. Oh. And what other notes did I have? The numbers, right? The hexyl has to be up. How do I know? It's a wedge. You chose a wedge. You made the decision. Which of these two bonds is up? Axial or equatorial? Equatorial is the one that's up. 1, 2, 3, 4, 5, 6, H. Isobutyl on the up or the down? Right here it's up. Right here it's up. Right here it better be up. Isobutyl. Ooh, it's not blue though. And H. Okay. So you're studying. What happens to a group when you go from one chair to the other? There's two things that happen. The blue group, focus only on the blue group. Was it axial or equatorial to start with? Because that's part of your answer for B. To start with, was it axial or equatorial? Axial. You can use the short form. I won't use the short form. It's not provided up there. But on your test, it says you can use the big capital letter AX. On the test, it'll say use AX. I don't have that here. And what about the, in the final chair, the second chair, is it axial or equatorial? Equatorial. So one thing you have to remember, when you go from a chair to another chair, all the axials become equatorials, all the equatorials, like this H, that used to be equatorial, what is it when you're finished? Axial. Don't label the H. It says label the R groups. What about the red isobutyl here? It is slightly up. So it's equatorial. The up part, slightly is what said equatorial to me. And started equatorial. Oh, I got busted. Oh, Dr. Yako would have a big chuckle right now. First draft of the textbook. Half the time I spelled equatorial like this, at least. It's not the equator of the earth, is it? It's not the equator. It's the equator. Yeah, equator. No quitters here. Okay, what about the red one? That's consistent. If it started equatorial, what's it end up? Axial. Now, the other part of that same question, if it starts up, then it ends. Don't dare say that. That is clearly in no estimation in this universe a down bond. Here's horizontal. Here's horizontal. Now make it as horizontal as possible. Okay. There's horizontal. Is that blue bond above or below? Is it this group? Sorry, I'm talking about the red one, right? I forgot. Which one are we talking about? The equatorial. Yeah, it's up. It's above that line. So what happens to up and down when you go from one chair to the other? Nah, don't even think that far. It stays the same. No, that's a separate question. What happens to axials in one chair when you go to the next? They all become equatorial. What happens to up in one chair when you go to the next chair? Absolutely nothing. Up is still up. You already covered the fact that it's a new type of bond. Okay, now one thing I haven't told you, and you will see in other videos, when you're axial, you are closer to other axials that are on the same side of the molecule than anything else. So if you have an axial bulky group, it's real close. And I'll just show it on this picture right here. I'm getting rid of my line. I don't like it. Maybe I'm not. I'm going to copy this right here. And I got extra apparently. Oh. Didn't copy the whole chair, huh? Wow. I don't know why it's doing this. Because it's time to crash. Okay, it didn't crash. That's what it does before it's going to crash, though. Okay, where was I? I was going to talk about axials being bad news. This red axial group is very close to this H and this H. It doesn't look like it, but they're very close to each other. And that interaction is called 1,3 diaxial repulsion. It's a form of steric hindrance. Form number 2 for you so far. We saw on adjacent carbons, if a group was in front of another group on adjacent carbons, we called it eclipsing, your first form of steric hindrance. Here, if you have groups on not adjacent carbons, but 2 carbons away, then they are very close in space because they're both sticking to the same orientation. And that's called 1,3 diaxial repulsion. If you don't write that at least 2 times on your test, you're throwing away 4 points. Okay? And here's the first time you're going to write it on your test. Question 1, which of the 2 groups, red or blue, is bulkier? And remember, the closer the branch is to the cyclohexane, the bulkier the group. And I purposefully chose one group that doesn't have a branch at all. So which group's bulkier? The red, yeah, isobutyl. So I do not want the chair where the red group is axial. Which chair am I going to circle for choice for C? The first one. Now I need a pen. I think it's going to crash again. It says normal pen up there, but highlighter down here. I don't know. Maybe I'm just paranoid. We're circling this in purple. And the words for D I need to see you acknowledge that the bulkier, and tell me which one's bulkier, isobutyl group, and tell me what it stays away from in this chair. Use those magic words you just learned. That's what I want to hear. All right. So right now you have a, let's see, about 6 points right there.
Can we draw the chairs the same way it is the first one?
No.
No?
Because when a chair does the sigma rotation, it doesn't look like the first chair anymore. I want to see you show that when you do the sigma rotation on that angle there, that used to be carbon 1, it rotated down to here. And there it is. This rotated, sigma rotated it down to here, and that's the result. And you want more practice with the same thing, don't you? Let's stop our video.